All right, so 31 now. 31, explain how the graph of y equals x squared minus 5 compares to the graph of y equals x squared plus 8. And this is just transformation. All right, so all it is that this graph right here looks something like this. The y-intercept is -5. So this -5 right here, right? That's -5 right there. It looks something like this. And this graph now, if you know, it's a +8. So the graph shifts up how many units? 13 units up on the y-axis. So the new graph is going to look something like this now, where this point right here is 8. That's all it is. So you compare the graph now. Wow, this is a hard-looking graph, but you get the picture, all right? Get a picture. So explain how the graph compares. Well, this graph, y equals x squared minus 5, right? It shifts up. Is it 13? Yes. 13 units, shifts up 13 units. 13 units. Okay. And number 32, state a new equation of the function y equals x squared minus 2 when it's moved up 4 units and right 2. That's a good one. So remember, the equation format is f of x is equal to a times x minus h squared plus k, all right? And so it's telling you now that the graph moved up 4 units. So minus, the graph is right here, -2 initially. Oops. It's -2 down here. It went up 4 units, right? So 1, 2, 3, 4. So now it's at 2 on the y-axis. So the k now is going to be a +2. It went up 2 units on the y-axis, and it moved 4 units to the right. Well, remember, if the graph moves to the right, it's going to be negative. So h is going to be 4. We can just replace a. Okay, that's it. So x minus 4, it moves 4 units to the left. I'm sorry, to the right, and went up 4 units. I'm sorry, it moved up. And oh, right 2. I'm sorry, right 2. I apologize. Right 2 units. So x minus 2. Good. All right, 33. Identifying functions, linear, quadratic. Okay. Well, by now you know this is exponential because of the x right here. Again, this is quadratic when the highest exponent is 2, right? That's going to be quadratic. Linear. By now you should recognize linear. When the exponent is the highest exponent is 1, so that's linear. Again, we have 2 right here, so that's quadratic. Come on. Again, this is graph of quadratic function, so that's quadratic. And you can tell from the shape of the graph, this is exponential. And then what do we have here? Oh, okay, let me erase this. All right, so look at G now. All right, now we're looking at tables. You look at the tables and look at the y values. All right, look how fast the y values decreases. It's going down real fast. All right, when x is 0, it's -1, but by the time you get to 3, it's at negative 216. So yes, that is decreasing fast. That's a sign of exponential. Now, when we have tables, how do we know, right? How do we know if it's linear or quadratic? Well, we can tell this is not exponential because the y values are not increasing or increasing fast. So that we can tell, it's safe to assume that it is not exponential. So we're looking at linear or quadratic. Let's look at J. Now for linear, we know that, right? The delta y is going to be the same. So if I take delta y here and here, they're going to be the same because the slope, right? For you to have a constant slope, those numbers has to be the same. Let's do that. So let's find the delta y of these two numbers. So we're going to say minus 4, right? Minus 7. And that gives me what? Well, this is a positive right now. So give me a positive. So negative 4 plus 7 is a 3. Let's look at our, the other delta y. 2 minus 1. This is a positive right here. So that gives me 3. So you see that I took 2 delta y's on the y column. I get the same number. So that's safe to assume then that this is linear. Now on H, let's do the same thing now and see what happens. Oops. Let's take delta y here and let's take delta y there. All right. Let's say 1 minus 0. 1 minus 0 is just 1. And 1 minus 4, right, that is negative 3. Okay, so that's not, if you notice now, the two delta y's they're not the same. So it's not linear, so it's safe to assume then this is a quadratic. All right, so to prove it, you can go you have to go further, but in this case, it's not linear, it's not linear, it's not exponential, so it has to be quadratic. All right. All right, 34. Okay, I feel like I need to explain this again. Let me go back and try this again. So remember, take the delta of the y values. When I did that, they're not the same. So because they're not the same, it's safe to assume then it is quadratic because it's not linear. These two are the same, so it's linear. I just want to make sure I clarify that. All right, 34. When stating domain of function, okay, this is your x-axis. All right, that's pretty easy. I hope you guys know that. And then 35, what's when stating the range, what axis? Y-axis. 36. Okay, 36 is how does the graph compare to? Okay, again, we did this before, guys. One very simple to this. Hopefully you know to do this. And if you're not sure, just graph both equations and see what it looks like. And so this one is going to be the y-intercept is -4. So let's call that -4 right here. And the other one, the y-intercept is 6. Let's call it the 6 up here. All right, that's 6. And so it went up 4 units and then 6, so that's 10 units, right? So it shifts up 10 units. It went up 10 units. Shift up 10 units. All right, 36. Okay, state the domain. Again, domain for a quadratic, for a parabola with no restriction, the domain is all real numbers. And for the range, well, let's see, this is the highest point on the graph. That's the highest point, and that number is, what is it, 2, 4, what's that, 6, right? 2, 4, 6. So this is, 7. All right, that's 7 right there. So it is, so y is less than or equal to 7. This is 7 right here. Number 38, given the equation, what would be the answer to x minus 3? Yeah, they're asking you, they give you this. You got to solve for x right here and then plug it in the x value right there. That's all you got to do. And so I'm going to do just minus 40 on both sides, minus 40 on both sides. That becomes 0. I'm left with x is equal to 37. All right, and then I just plug in 37 over here. When x 37 now, I'm going to have 37 minus 3, which is 34. That's it. Okay, state the number 39. State the equation. This is a pretty simple one from the first couple of weeks. How do you write the equation for this? Well, it's a table. I recognize when x is 0, what is 5 going to be? That's my y-intercept, right? So b is equal to 5. So all I got to do is find my slope now. So delta y over delta x. So I'm going to have 3 minus 1 over minus 1 minus negative 2. That becomes 2. This is what? This becomes a plus sign right here, right? Big plus sign. That gives me 1. So my slope is going to be 2. So m is equal to 2. So my equation now is going to be y is equal to 2x, and my y-intercept is 5. 39. Number 40, state the key features. Key features, guys, let's see. Well, the vertex is right there, and that is -1, -9. So the vertex is -1, -9. It's a minimum, right? Because the graph opens upward, so it's a minimum. The y-intercept is 0. That's 9, so this has to be 8. The y-intercept is 0, -8. The zeros, my zeros on my x-intercept are going to be -4 and 2. What else? I think that's it, right? Yeah, that's it. We can say the domain is all real numbers. We can say the range is greater than or equal to, okay, let's put it there. We can say that the domain is all real numbers. All real numbers. And we can say the range is y is greater than or equal to -9. Is -9? Yes. All right. So that's 40. Okay, 41, almost there. State the key features. Well, this is a linear graph. What are we looking at? Well, the y-intercept is 0, -4. The 0 or the x-intercept is 1. We can say this slope is increasing, right? M is increasing. It's a positive slope. M is positive. Okay, what else can we say about that graph? No. And 42, is this my last one? No, I got 42. All right, 42. All you do here, guys, you can do 2 ways. You can graph the function on the calculator, right? And then find where x is 2 and find the corresponding y value. Or if not, you can solve it. So g of 2 is going to equal to 2 times 2x squared minus 3 times 2 plus 4. And you simplify that. 2 squared is 4. 2 times 4 is 8 minus 6 plus 4. And that should give you 6, right? Am I right in saying that? Yes. Equals 6. The next one, g of 2 is equal to 3 times 2 plus 4, and that is 10. This one is an exponential now. G of 2 is going to equal to 4 times 3. The exponent is 2. So here it's going to be 3 squared. 3 squared is 9, right? It's going to be 4 times 9, which is 36. Right? And then D is G of 2 is going to be negative 2 squared plus 5 times 2 plus 6. That is negative 4 plus 10 plus 6. And 16 minus 4 is 12. I hope I didn't make a mistake on these. All right. And then 43 is simplifying radicals. All right. Can I scroll down a little bit? This thing's in the way. Okay, let me move my taskbar, guys, so we can get to our. Do I make it smaller? Will it show up? View, zoom, 100? Nope. I got to move the taskbar. It's in the way. Let's see. Move it to the left. All right. There you go. All right. So let me extend the page so we can do this right here. All right. So remember we did this in class. Simplify radical 18. How do we do that? We're going to divide by the smallest prime number, right? And so for 18, it's going to be 2. Divide this by 2, that gives me 9. Divide 9 by 3 because the smallest prime number, 3 divided by 9 divided by 3 is 3. And 3 divided by 3 is 1. So you want to do this until you get 1 on the right side. That's how I teach my guys. All right. And so we have 1 pair of 3. That's 1 pair of 3. That's going to give me a 3 right there. This doesn't have a pair, so it stays under the radical. So I'm going to have now 3. This 3 goes outside the radical. And because this is just 2 by itself, it has no, it does not pair, it goes under the radical, and that's it. Okay, B is square root of 84. All right, square root of 84. I'm going to divide by the smallest prime number, which is 2. That gives me 42. Again, just divide by 2 again. That gives me 21. The smallest prime number is 3. It gives me 7. I'm sorry. I guess what I get 21. Sorry. 7, and then I divide 7. The smallest prime number is going to be 7. 7 get 1. Notice now I have 1 pair of 2, so that's going to give me a 2 right here. These 2 don't have a pair, so it goes back under the radical. So that's going to give me now 3 times 7 goes under the radical. 1 pair of 2 stays outside, and that gives me 2 radical 21. That's the answer. All right. Okay, let's try. That was B. Let's try C, which is radical 48. Okay, divide this by 2, that gives me 24. Divide that by 2, that gives me 12. Divide that by 2, that gives me 6. Divide that by 2, that gives me 3. And then divide this by 3, it gives me 1. So now I have 1 to right. I know I'm done. Let's see how many pairs I have. I have 1 pair of 2. That gives me a 2 right there. 1 pair of 2. 2s, that gives me a 2 right there. The 3's by itself, so it stays inside the radical. So I put my radical, the 3 goes there. I have 2 pairs of 2. 2 times 2 is 4. 4 radical 3. And the last one is radical 124. Okay, radical 124, divide that by 2. That gives me 62. Yes. divide that by 2 again, that gives me 31. And guess what? 31 is the highest number I can divide this by. So 31 divided by 31 is 1. I have one place of 2, so that gives me a 2 right there. 31 is by itself, so it goes back under the radical. 31 goes there, and we have a 2 on the outside. All right, guys, I think that concludes all the questions on the review. I hope this helps you.